In West Philadelphia, born and raised, on the playground is where I spend most of my days. Chilling out, maxing, relaxing, all cool, and I was shooting some b-ball outside of school when a couple of guys who were up to no good started making trouble in my neighborhood. I got one little trouble, my mom got scared and said she had a little trouble going on to you, Bel-Air.
All right, we are looking at some, I don't know who those rappers were.
I don't either, but man, that was a good concert.
That was pretty good. I enjoyed that greatly. All right, so we are looking at dividing today. We got some vocab coming at you first. And I always like to do it with a picture. So you can see on your notes there's a little box with a picture. If you can't read some of the words, go ahead and write over it as I go through it. When you look at a division problem, so let's say I have a problem that looks like this. And I've got maybe, 435 divided by 5. What I do is I've got a number, and then I'm going to have a number up there. So these all numbers have names in division. First off, the big number inside is called the dividend. And one thing that Mrs. Roy likes to say that helps, if they write the problem horizontally, so let's say they write it like this, it would actually be the one on the end. So see how this number's in the middle? But this number's on the end, so that's how you can remember that it's the dividend. Oh, thank you.
I gotcha.
All right, so the divisor is the number always on the outside. So like in my picture, it's the number on the outside over here. And this one, it's a 5. Your quotient is always going to be the remainder. Or not the remainder. Your quotient's going to be your answer. So the quotient is the result of a division problem. And she already filled it in for me and knew it was 87. And now let's say, let's change it one number. And let's say I've got 436. And I would have 87, and then I'd have 1 left over. So I would put a R for remainder, 1. So I would have a remainder 1, and that's where you put your remainder. So that's just what's left over, what won't go completely into the problem. We're going to talk about how to know what these remainders mean here in a little bit. But there's your vocab to start off. All right, now let's do some problems using this terminology that we've just talked about.
Okay, so we're going to start looking at basic division. The part where you may think that it's just going to go away, but it really isn't going to go away, and you really have to just know it.
Never going away.
Can I use that good marker that you had? Okay, so the thing that I like to remember is that in my dividend, the number inside of the box, there always has to be a digit above that number in my quotient. Always. Whether it's a 0, whether you're just holding it with nothing and it's a placeholder, or it is an actual number, there's always something above each number in your dividend. So I know for sure I'm going to have 2 place values here, okay? So we're going to start here. We're going to look. How many times will 5 go into 7? Well, I'm going to think back to, also I want to remind you of dad, mom, sister, brother. Right now we're in the process of dividing. 5 goes into 7 one time. If I've got 7 children, I can only have one group of 5. Then I've got 2 left over, right? So 5, I'm going to multiply now. 5 times 1 is 5. Now I'm going to subtract. 7 minus 5 is 2. And then lastly, the B stands for bring down. So I'm going to bring down that 5. I have to bring down these numbers. I cannot stop until I brought them down. Eventually, you're going to get into 4-digit dividends. And you're going to have to bring down. You're going to have multiple arrows leading down. And I like you to use the arrows to show where your numbers are going, okay? So now we're going to start the process all over again. We're going to start with dividing. How many times will 5 go into 25? 5 times what is 25? Well, I know 5 times 5 is perfectly 25. So I just did multiplication. I'm going to write down my 25. Now I'm going to subtract 25 minus 25, 0. And then the B is finished because we have nothing left to bring down. There's nothing out here. So in this case, I had no remainder because my answer was 0. And then I can check and make sure, do I have one number above each of my dividend place values? And I do. I've got one number above. So my quotient is equal to 15. Okay? Now let's take a look at another one. Kind of the same type of problem. Oh, I shouldn't have erased that. Dad, mom, sister, brother. The next problem is 45 divided by 3. So let me show you that again. We're going to divide first. 3 will go into 4 one time. If you think about it, you can't go over 4. So 3 times 2 is 6. That's too much. So 3 times 1 is going to be 3. The next step is to subtract, sister. 4 minus 3 is 1. And I'm going to brother bring down. Then I'm going to start all over again. Dad, mom, sister, brother. 3 goes into 15. Well, I can think of my math facts. 3 times 5 is 15. And I already did the multiplication, so 15 minus 15 is 0. And again, this one came out to be nice and pretty. I have no remainders. Okay? Let's take a look at one that will have a remainder so you know how to write that. 74 divided by 6. So, Miss Rutledge, let's see if you've learned from watching the video. 6 goes into 7.
Well, I have to do just the 1. I can't do 74 because that's too big, but 7, it goes into 7 one time.
One time. Good job. What do you do next?
Now I do the m, so multiply. I multiply my quotient number times my divisor. 1 times 6 is 6. Then I subtract. She already gave me the answer.
Give it to her.
7 minus 6 is 1. 6, it can't go into 1. Oh, I forgot to bring down.
You forgot to bring down. She was trying to divide. She messed up.
All right, 6 goes into 14. Well, it could go in 2, and that would be 12. 3 would be 18, so that's too many. So only 2 times.
Can't go over.
So 2 times 6 is 12. Write that underneath. I love how you're keeping your lines so straight.
It's
That's
really
a
important.
Good idea.
It's
yeah.
really, really important.
And then 14 minus 12 is 2. And then I'm supposed to bring down, but I don't have anything to bring down.
Okay, so this number is not a 0. What do you do with it now?
Ooh, that would be, since we're at the end and it's not a 0, we have to do an R for remainder. And I always tell my kids capital R because sometimes your lowercase r's are hard to read, and I think that it's like a number or something. R, and then it would be 2 because that's what my remainder was.
So 12, remainder 2. And you can't write a remainder until you've made sure you've brought down any numbers. So we didn't have any more to bring down. We brought down the 4, and he was the last one. So we knew we had a remainder left that time.
Yep.
Okay?
Okay, I'm going to work with you on some word problems, your favorite, and talk about what do we do with those remainders? What do they mean? Because, you know, a lot of times we get really good at putting R2, R3, but what does that mean in, like, real life? What do you do with remainders in real life? Okay, so look at question number 4 on your lovely paper. It talks about 174 guests invited to a dinner. Mrs. Roy, have you ever had 174 people over to your house?
No, at my wedding.
Oh, at our wedding.
Yeah.
Ooh,
Yeah,
this would be
right,
a good wedding situation. I hope to have one of those one day. Okay, so 174 guests at a dinner, maybe a wedding, and each table seats 8 people. So, how many tables are needed? Well, so we need to figure out first, well, 174 people, and each table holds 8, so we're going to have to divide that. And Mrs. Roy is so nice.
And can I tell you why this would be important? Because let me give you a little lesson here. Tables cost money, and when you're planning a wedding, you don't want to spend too much of your budget. So you have to be able to know exactly how many tables that you need to buy.
You don't want to buy more or less than you need.
That was my nerd status.
All right, so 8. How many times can 8 go into 1? Oh, it can't go into 1.
But you have to have a number above each digit.
Oh, so I'm going to say 8 cannot go into 1.
Let's just do this.
So put a 0.
It's kind of like a dash 0 because it's like not really there.
Oh, it's
Just like placed.
an imaginary 0 apparently.
Yeah.
So then I go over. How many times will 8 go into 17? Well, I know 8 times 2 is 16. That's really close. So I'm going to do 2 and then multiply and get 16. So then I subtract and have 1, and then I'm going to bring down my 4. So how many times will 8 go into 14? Oh, well, 2 is too many, so just 1 time. So 1 times 8, and then I've got to subtract. Ooh, and that's going to be 6. So now that we have this, we have a word problem. We have to think of what this is. Our answer, 21, is going to be, did I do that wrong? Oh, I did it wrong on there. Okay, so our answer here is going to be 21 what? Well, it asked me, each table seats 8 guests. How many tables are needed?
You can just
So
keep talking.
really, it's going to be 21 tables. But what I have left over is, my remainder is 6 people. Because these were people. So let's think about a wedding. I've invited 174 people. And I am going to buy tables, and I know each one holds 8 people, and I have 6 people that won't fit at one of my 21 tables. So
Send them home,
Yeah.
Mrs. Rutledge.
maybe just tell them, oh, we didn't actually want you here, but what if the 6 people that didn't get a table were like my family, and then they would be really mad because they didn't get a table. So,
Make them sit on the floor.
yeah, not at a wedding. They are like dressed really nice and stuff. So we have 3 options you can always consider. You can consider rounding up. So I could get 22 tables and just have those 6 people sit with 2 empty seats. I could drop it and just tell those 6 people to go away. They're no longer invited. Or I could keep it and build a table for 6 people. I'm going to vote with number 1. I'm going to round up. So
She's way nicer than I
in
am.
this one, in this circumstance, I would want to say, not 21 tables. I'm going to want to say, go ahead and get 22 tables. And what we call that is when it says interpret the remainder, you're going to explain. So I round up, and then you just have those 6 people sit there.
I hope one day that if I'm one of those 6 people, you get another table for me and don't do what I did.
Yeah, that's
send me
probably
home.
the nicer thing. And here you can't try to explain to me and Mrs. Roy why your idea is the best. You really need to consider the circumstances. So if you've invited people, you better have a place for them to sit. Okay, let's do the next one. We're talking about tents here, and a tent needs 7 poles. And we need to find out how many tents we can put up with these. And we have 200 poles. That's a lot of poles. That is a ton of tents. So, first off, look at her go.
Just
We
magical
know
appearance.
200 poles, and I liked how she labeled it last time.
Well, if you label them, then you never use the label twice.
That's true.
So you kind of know that if the poles are down here, they can't be up here too.
Okay, and we need 7 for each tent. Is that right? So this would be, each one needs 7
Yeah,
each.
each pole.
And then however many that will be, I can already tell you my label. This is going to be my tents. Okay? So let's
Will that
see.
answer the question?
Huh?
Will our quotient answer our question? Our question said how many tents can be put up.
Well, we'll have to
So it
interpret
should,
that.
won't it?
Yeah.
But that's my label
Have
right
to
there. It's in my
interpret that
question.
remainder and see. All right, 7 can go into 2 0 times. You can put an invisible 0 like Mr. Roy did. I usually just put a normal 1 because I have to have something above there. 7 can go into 20. Well, 3 is
Too
20,
much.
21. Off by 1. All right, so it can only go in there 2 times, which is 14.
Notice that she put it right above that placeholder right there.
Yep.
She asked about 20.
So I've got 6 left over. Ooh, you can always tell because this number should never be bigger than this number. All right, I got to bring down that 0. How many times will 7 go into 60? Well, 8 is 56, but 9 is 63, so it's going to have to be 8. All right, and that's 56, so I've got a remainder of 4. All right, so now let's talk. 4, my label was poles. I can actually bring down that label. Haha, bring down the label. Okay, so let's think. We got 3 situations. First, I could round up, and I could try to make a tent work using 4 poles. We really need 7, but we're only going to use 4. What would happen if we did that?
I think quite possibly the tent might fall over.
It might fall over. Okay, so there's that idea. We could drop it and just say, meh, we already got 28 tents. We'll just have 4 poles left over. We'll just leave it at 28 tents. Or we could just keep it. So we could just be like, well, I got 4 poles. I'll try to stick them in wherever I can.
Maybe some tents will get 8 poles, but there's not a spot for...
Yeah, there's not a spot for 8 poles, but maybe they could have 8 poles. So we got 3 options. Ms. Roy, which one would you choose?
I would just probably pack those 4 poles up and put them back in my car.
Yeah. Don't throw them away because you could use them eventually.
Or
But
you could buy 3 more poles.
so I'm
Make
not
it a
going to
10.
round up. I'm actually just going to drop it. I'm just going to forget about these 4 poles. Put them in your car. You could throw them away. And then my answer would just be 28. So I'm going to say 28 tenths is all I can have. And what I did was I dropped it. So you've got to really think through these problems you're going to be doing today and make sure that it makes sense. I like to talk through every option. What does it mean if I round it? What does it mean if I drop it? What does it mean if I, what's my other one? Keep it. And think through those and see what would be the best. Don't try to be mean here. Try to make the best possible choice.